So welcome to Focus by Virtuation. I'm your host Seshungu. In this particular video, I'm going to show you a way to try and categorize and memorize all organic chemistry reactions. This is advanced level chemistry. So our reactions are going to be categorized into those four main categories: oxidation, reduction, esterification. We're going to look at halogen carriers, reactions that are driven by these halogen carriers, and we're also going to look at the fourth one, which is the peculiar one, the nitrogen oxygen analogs. So I'll begin with that one because it's the uncommon one. So what are these? So it's an idea that you need to use to try and simplify things for yourself. Think of water and ammonia as where this idea begins. So you can think of ammonia as the nitrogen version of water. So here the only difference is that nitrogen in this case is going to be able to make 3 bonds instead of 2 bonds. It has a lone pair there, and water also has a lone pair that it can donate, etc. But just think of ammonia as the nitrogen version of water. So these are analogs of each other. Okay, so we need to look at our organic molecules in this manner. So if we look at that nitrogen-based molecule, this would be an amine. So you can challenge yourself and ask yourself, what would be the oxygen version of this molecule? So what you simply have to do is replace the nitrogen with the oxygen. So you realize that the closest member to this one is going to be ethanol. The oxygen version is going to be ethanol. We'll simply put oxygen where there was nitrogen, and since oxygen can only form 2 bonds there, that's why we have 1 hydrogen instead of 2 hydrogens as it is in the amine. So this kind of thinking, you can take it to the reactions and see what similarities are there. Okay, so let's move on here. That molecule has a nitrogen version, so it has an oxygen version. So we simply have to replace the nitrogen with the oxygen, and if we do so, we have ethanol. So we have simply put oxygen where there was a nitrogen there. We have attached oxygen to the carbon to which the nitrogen was attached, and since oxygen can only form 2 bonds, we have 1 more bond that the carbon can form. This is why we have the H there. Okay, so this kind of thinking, though at start it might seem to be challenging, but you see that that's the best way to think about these molecules, that there's an oxygen version and a nitrogen version. Okay, so if you look at the reactions, they are going to be similar because of this way of looking at things. You're going to see some similarities which will help you to remember these reactions. Okay, so let's start off with those 2 reactions. So that's on top there is my nitrogen version and my oxygen version at the bottom. So if you were to reduce those molecules, what would you get if you were to reduce? So you can see that for the nitrogen, we have formed our primary amine there, and for the oxygen version, we have formed our primary alcohol. It's the same reaction, which is a reduction. So look at what has happened. We have simply added hydrogen to the triple bond on top, and we have also added hydrogen to the double bond at the bottom for oxygen. Let's move on. If you look at that molecule, which is ethanamide, it has its oxygen version, which would be ethanoic acid. So that's a nitrogen-based acid, if you want. You can think of it that way. It's a nitrogen-based acid, ethanamide. So its oxygen version is ethanoic acid. So if you think that way, so we are simply saying the nitrogen has been replaced with an oxygen in the acid. Now, looking at the reactions, how would you form a carboxylic acid? we are back to water and ammonia. So if I took an acyl chloride and I reacted with water, then I can form a carboxylic acid and hydrogen chloride. If I did the same in the nitrogen version, what I would need is ammonia instead of water. So if I reacted my acyl chloride with ammonia, I would get a primary amide, so, and HCl. So you start to see similarities when you think of the oxygen version and the nitrogen version of the same molecules. So hopefully this helps. Let's move on. So we're back to water and ammonia. These are analogs. So this is the basic idea. You need to think of organic molecules this way. There's an oxygen version and a nitrogen version, and you start to see similarities as you continue to apply this concept. Okay, if you look at that molecule, there's a link there which makes it these are called N-methyl ethanamide. The oxygen version would be methyl ethanoate. So those two molecules are similar, only that in the other one there is oxygen, in another there is hydrogen at those points. So how would you form these molecules? Okay, so if you took an acyl chloride and reacted with an alcohol, you'd form an ester. So that's an ester link. If you took an acyl chloride and reacted with an amine, which would be the nitrogen version of an alcohol, you would form a secondary amide. And of course with HCl and also HCl in both cases. So hopefully you continue to practice that kind of looking at organic molecules, and it's going to help a lot, as you shall see.